Let's go over midterm 2 from winter 2020. We're asked to download some data on New York City residential sales. And it has information on individual sales of residential properties in New York City in 2 years. It's from NYC Department of Finance on Open Data NYC. We have a sale date, sale price, address, geo, which looks like it includes zip code with NY at the end, longitude and latitude, borough, building class category. So let's open a workbook and let's connect to that data, NYC residential sales. And you can see what that data looks like. All right, there it is, borough. So these are the codes. One is a neighborhood, building class, block, address, apartment number. Oh, there's actually a lot more than what is listed there. There's a sales date, longitude, latitude, sales price. Here's the geo. Okay, it looks like a zip code, and then dash NY or hyphen and NY. Okay, fantastic. So what's our first question? We're supposed to create a dimension that contains names of the boroughs rather than a numerical code. Which borough had the highest median sale price? Okay, so borough, it looks like a number, but we don't want it to be a number. We wanted it to be dimension because it represents something that's countable, a borough. So let's convert it to dimension and let's create aliases. One is, I have to go back here. So Manhattan, Bronx, Brooklyn, Queens, Staten Island. All right, so Manhattan, Bronx. So one is Manhattan, Bronx. It was number 3. Brooklyn, Queens, and then Staten Island. Brooklyn, Queens, Staten Island. Okay. Fantastic. So we've got that dimension. We can put it on rows, and we can put sales price into the table. Actually, we're supposed to put together a bar chart. Okay, bar chart, not sum of sale price, but rather the median sale price. Okay, fantastic. You could see clearly Manhattan at the highest median sale price at 1.1 million. Create a dimension, it could be a group, we'll call it type, that consolidates the 14 building class categories into 4 types: condos, family, rentals, co-ops. Okay, condo co-ops should be part of co-op. Create a horizontal bar chart showing the median sales price by each type. Okay, so we've got this building class category. It has 14 different values. We want to consolidate them. So one way we could consolidate them is by creating a group. So let's do that. Building class category, create group, and we're gonna put family dwellings, all of these family dwellings into family, condos. Well, this is going to be part of condos, and so these things also go into condos. Fantastic. Rentals, let's group them into rentals, and co-ops. That's a separate category. And rentals, we move to rentals, and here we have more condos. It should go under condos. And what did it say? Condo co-ops should be part of co-ops. Okay, so we'll do that. Condo co-ops, part of co-ops. Fantastic. All right, so we categorize them. Let's name this group type. So type of building, and we can actually see here, yes, that condos, a part of condos, co-ops, including condo co-ops, family rentals. Fantastic. So we can actually take this one out, and we're supposed to create a bar chart, horizontal bar chart, showing the median sales price by each type. Okay. So sales price is here. We're going to put it on columns, and we'll change it to median. Now, question 3, create a symbol map plotting the location of each property. Color each property according to its type. Okay. What does the map tell you about the distribution of different types of properties throughout the city? Okay, so let's do that in a new sheet. So a symbol map. Now, we want to plot the location of the sale. So let's put a longitude on columns. Let's put latitude on rows. And it gives us average longitude and latitude. And now each sale is really defined by address and an apartment number. Probably, I mean, that should be it. I don't think that you could have different building class categories in the same address. So let's leave it at this. We have 100,000 marks here. There could certainly be some properties sold multiple times within those 2 years. So this may not be exactly equal to the number of observations, but it clearly tells us all the addresses and apartment numbers that were sold in New York City. Let's color it by type. And okay, very nice. Let's make those dots a little smaller. So there seems to be a lot of overlap there, and we can zoom in, and I think we can see some pattern here. We can definitely see that Staten Island and Brooklyn and Queens over here, those are family dwellings. Those are basically single-family houses, whereas Manhattan has single-family houses. Right? It has condominiums and co-ops. That pattern is quite. Create a filled map by zip code, where the lightness of each zip code is proportional to the median price of the properties sold in that zip code. Which area of New York City has the highest prices? Okay, fantastic. So for this, we're going to need a zip code. And we don't have a zip code. We have this variable called geo, which we can see contains a zip code, but it has this additional hyphen NY. And so Tableau did not recognize it as a zip code. It didn't give it geographic role. So let's create a zip code. Let's create a calculated field, and let's call it zip code. And how do we do that? Well, we could do it. We could take the first 5 characters, first leftmost characters of geo, because the zip codes are 5 digits. So the first 5 digits is going to give us a zip code. We could do that. We could also replace the dash NY with nothing, with an empty string. That would work as well. So let's do that one. Let's do replace geo, and when it finds hyphen NY, it should replace it with nothing. The calculation is valid. We'll say OK to that. Now, Tableau still thinks that this is a regular text field, but it actually has a geographic role. So we're going to assign it zip code as a geographic role. Now it has a little globe next to it. And double clicking on it, it's going to plot the zip codes that we have. You can see these are New York City zip codes. We want this to be a filled map. Awesome. And we want the lightness, the intensity of the color proportional to median price. Okay, so let's go to back here. So we'll do sales price, map it to color, change the method of aggregation, not to sum, but to median. And we can see quite clearly that Southern Manhattan, here's the Tribeca neighborhood, that is the most expensive area of New York City. Next, create a dashboard showing the map from question 4 and a bar chart from question 2 and another horizontal bar chart showing the volume, the number of transactions of sales by type of property. So we need the map from question 4, bar chart from question 2, and another horizontal bar chart. So let's create that horizontal bar chart first, showing volume by type of property. Let's do that. So type of property is here, volume of transactions. So we just need a count, how many transactions we had in each type of category. We have family, 50,000 transactions in family, dwellings, a bunch of co-ops, condos, and so on. Rentals, not a huge volume in there. Okay, we could probably, well, we can color these, but let's leave them blue, and let's create a dashboard. So in the dashboard, we're supposed to put the map, and we're supposed to put the bar chart, and we're supposed to put the other bar chart. And we could probably adjust how this looks. Could probably spend a lot of time deleting the titles and so on, but this is roughly, let's make this one floating, what the dashboard looks like. We've got the map, we see what is the median sales prices by categories and what's the volume in each type of building. Okay, in question 6, we're supposed to create an action whereby hovering over zip code on the map will cause the 2 bar charts show values for that zip code. So let's do that. Let's add actions, and it's going to be a filter action. The source sheet is going to be the map, which is sheet 4. The target sheet is going to be sheet 2 and sheet 5, which are the 2 bar charts. We want to run the action on hover, and I believe that's it. So I'm going to say OK to that. I'm going to say OK to this, and it's working. Here we go. Well, let's go to that Tribeca neighborhood, where it's condos and rentals. That's what probably drives the prices. 7, create a bar chart that shows the change in the share of property type in the transaction value between 2017 and 2018. Which property type increased its share, which decreased? All right, so let's do that on the next sheet. And so here we want to look at share, like where the volume or the value of a transaction took place in each year and how it changed over the years. So let's put the date aggregated up to a year on columns, and let's put type also on columns, and let's put the sum of sales price. Yeah, let's put it on rows, and let's actually color it by type so we can keep track what is what. And And this gives us really the value of sales in each property type. We could see condos did 24 billion worth of sales in 2017, a little less, almost 20 billion in 2018. But I want shares. I want to know, okay, what's the share in each type? So for this, I could definitely do a table calculation. I could do a table calculation and ask for percent of total, whereby I want a percent of total in each pane. So because I want a percent of total in 2017 and percent of total in 2018. So pane across. Yes, that's correct. So the percentages really add up within each year. We got 35 plus 20, that's 75, plus 30. Yeah, no, that's a lot. That doesn't add up. Let's see, 15, that's 45, 45, 15, 45, 20 is 65 plus 35 is 100. Okay, so they add up to 100. And we actually see quite nicely that condominiums share dropped from 35% of total value of sales to about 30. Right, so by about 5 percentage points, their share went down. The share of really rentals went up in 2018, right, from 15% to 21%, so by 5 percentage points. Okay, so we could certainly use this to indicate this is what is the change in the share of each property type across the 2 years. But perhaps we would like to have a bar chart that actually shows the change in the share. Rather than share in 2017 and share in 2018, let's just show one chart that shows the change. So for condominiums, let's show how the share dropped 5 percentage points, and for rentals, how the share went up about 5 percentage points. So ideally, we would love to do another table calculation, right, to show what's the change in from 2017 to 2018. But we already have a table calculation here. We already have a table calculation of percent total, and we cannot do another one on top of existing table calculation. So we need to calculate the share manually. We need to create a new dimension that would, or new measure that contains the share of sales of a particular type in total sales. And for that, we'll need a variable that gives us the total sales in a given year. For that, we need to create a calculated field, which we'll call sales by year. And it's going to be a LOD expression that's fixed at the year of sale date. And we're going to add up sale price. So this is going to aggregate within each year, adding up sales prices across all properties, across all types. We can see how something like this behaves by putting up a chart and let's say putting up a year in columns and sales by year. Since these are aggregated at the annual level, they don't vary by type because we fix the level of aggregation at the year, not at the individual row or at the individual type. So we could see that that number actually doesn't vary across property types, because it just gives us the total volume or value of sales in 2017, and the same for 2018. So now that we have this, we could calculate the actual share. And share will be sum of sale price, divided by sum of these sales by year. Okay. I'm going to say okay to that. Let's actually put it in here. Let's change that to percentage. Okay. So there we go. Here we see condominiums had a share of 35% in 2017 and dropped to about 30% in 2018. So this is exactly the number that we wanted. So let's go back to our bar chart, and let's replace this table calculation with the actual manual calculation of share. And you can see that this really didn't change anything. I'm sure we should probably format the axis so that it's in percentages rather than decimals, but for now we'll leave it. But now that we have an actual measure, we can now include a table calculation on that measure. So I'll do add table calculation. We're going to do difference from really year of sale. Exactly, because we want to see what's the difference from one year to another. And here we see that the condominiums share dropped about 5 percentage points. The share of rentals increased about 5 percentage points. So so there, that's a chart. We could hide 2017. We don't want to exclude it because we need that 2017 data for the table calculation, but we don't need to show it because there's no bars for that. But this gives us a sort of much more concise and more direct way of seeing whose share went up and whose share went down. Let's go to number 8. So in number 8, we're supposed to connect to another data source. Some demographics contains demographic data on New York State zip codes as of 2018, comes from American Community Survey, includes the following variables. Connect your existing Tableau workbook to this data source. Do not join the data, only have your workbook connected to 2 data sources. Okay, let's do that. So I'm going to go back to our data source tab, and we're going to open a new data source. We're going to connect to a text file. That's the NY sum demographics by zip. We'll say okay to that. And here we see the zip codes. It's called geo.id2. We see median income, population. All right. State is New York. Perfect. I think we can work with this. Now, what are we supposed to do? We're supposed to create a map showing and annotating that zip code. Okay, so which New York State zip code has the highest median household income? So we have a median income. That's the field that we're supposed to focus on. So let's, what do we do? Should we plot it? Should we do a table? I actually think that it would be nice to plot it. Since we have a zip code here, let's assign this field, this geo.id field, a geographic role. Let's make it a zip code, postcode. Let's double click on that. There, those are New York State zip codes. Let's make that a build map. What is it? Build map, sure. And let's color it by median income. Median income, let's turn that into a measure. Probably has some, okay, let's not do that. Let's fix it. Median income. Why does it show up? It shows up as a text variable because there's an NA row with NA, so it thinks it's a text. Let's change the type to a number, whole number, rather than a decimal. And now we can turn that into a measure. Put that on color. So we have all these zip codes colored by median income. You see that it ranges from 12,000 to 242,000. Of course, it's hard to tell which one is the richest, which one is the darkest one. It's probably somewhere around New York City. But let's use the table calculation, rank table calculation, to tell us which zip code is number one. So let's put the median income on a label, but turn that into a table calculation where we use rank. Let's make it unique in case there's a tie. And we're going to do it across the zip code. So we're going to X that out, and let's now use that table calculation on a filter. Let's keep it just rank number one. Whoops, it looks blank. It looks like there isn't any. But actually, if we look closer, if we zoom in down to the bottom of Manhattan, there is our richest zip code with 242,000 median income. We're supposed to annotate this mark. So we're going to annotate mark, and we're going to say richest zip, about that. Can certainly get fancier, but for the purposes of this video, I think that will do. So in question 9, we're supposed to create a scatter plot that uses the median income on the x-axis and median sales price on the y-axis. Now the median income is in the census data and the sales price is in the residential sales data. So we're supposed to combine information from those two different data sources into one sheet, and we're supposed to do it using data blending. I don't always cover data blending, but I did cover that in winter 2020. So let me go over the answer to this question. So we need to tell Tableau how to link those two data sources, because right now there are no common fields between them. And so we can do that by going to data and edit a blend relationship. We're going to select the residential sales as the primary data source, and remove this and use the demographics data as the secondary data source. We're going to add a custom blend where we're going to link a zip code in the residential sales data to GeoID, which contains a zip code in the demographics data. I'm going to say OK to that. And now we're going to create a scatter plot. We're going to start with the residential sales and put median sales price on the rows shelf. That's the y-axis. Let's make it median. Let's put the median income from the census demographic data source on columns. And it's asking us, well, look, I need to link it. Now we have a GeoID. It's offering us as possible link right now. To activate that link, we're going to select that in this view, Tableau should link the demographics and residential sales data using GeoID and zip code. Now, of course, we need to use a level of detail. We need to have this done by zip code. We have 179 marks. That's the number of zip codes in the New York City area. It's not 1,700 zip codes in New York State. It's just zip codes that exist in New York City. And we clearly see that there's a positive relationship. Zip codes that have high median income also tend to have high median sales price of their properties. We could certainly add a trend line to this relationship to see, all right, there's a positive relationship. We could probably also put borough on color without the trend line. I'm gonna edit the trend line. We don't want them to be by borough. We just want one trend line. But we can nicely see that Manhattan are the zip codes with high income and high residential sales prices, and Bronx in orange is here the low end, low income, low residential prices. So that's it. That's question 9 and midterm 2 in winter 2020.